Okay, so we're going to go over there it is, similar triangles question. This ridiculous picture here represents a ladder. So this is a ladder here. It is a 10 units, meters, centimeters, whatever you want to measure it in. It is 10 units long, okay? And it's placed against, obviously, the wall. We're going to say the wall is standing upright and the floor is relatively level. So we're going to say it builds or creates a 90-degree angle at the wall. There is also a similar ladder placed right underneath it. Very dangerous. And it is only 6 units long. The one other piece of information we do have is that the longer ladder is 4 units, or meters or centimeters, whatever it is, from the wall itself. So the base of the ladder to the wall is a distance of 4 units. So since we have that, we're going to say that this question is asking us for how far away from the wall is the base of the ladder and how high up does the wall, is the tip of the second ladder, that smaller one, what are the measurements of this? That's what we're really trying to find out. So we have two, actually we have three. And anytime you have a triangle, you need at least 3 pieces of a triangle to solve for the rest of the information. So this is 10, this is 4, and this is 90 degrees. So that's 3 pieces. That's really, really helpful. Because this is 90 degrees, we can use Pythagorean's theorem to solve for the other side, how high up the wall the first ladder is. So Pythagorean's theorem in a formula is written as a squared plus b squared is equal to c squared. The a and b are the legs of the triangle. Legs being the opposite of, not the hypotenuse. The hypotenuse is always opposite of 90 degrees. So the hypotenuse in this case is our ladder. It's 10. So the legs, A and B, this could be A and this could be B, or vice versa. This could be B and this could be A. It doesn't actually matter which we call it. We'll just label them to help us out. That's going to be A, and this is going to be B, we're going to say. Great. So let's plug in for A. A is 4, so we're going to plug the number 4 in here. So we get 4 squared plus B is still unknown, as we can see, squared. And C, well, C is also known. It's 10. So we're going to plug in 10. 4 squared is 16. B squared is B squared. And 10 squared is 100. We're going to bring 16 to the other side. Okay. So that's going to be 100 subtract 16. B squared will be equal to 84. I think that's right. And then to isolate our b, we need to square root both sides of the equation. Okay. When we do that, this cancels out our squared on the left here, so it's going to be b is equal to root 84. Now, this is not a whole number, so I'm going to bring out my calculator. It's going to be 90 something. All right, I think so. 84, there's square root. 9, not 99 something, 9.1, we'll say. So we say B is approximately 9.1 units. Great. Let's move this picture over again. Okay, so this is 9.1 units. Wonderful. But we said that the most important part about this is we have to find out the information here. So we have what are considered 2 similar triangles. Similar triangles are triangles that actually have the same angles. Okay? The same internal or interior angles. So these 2 triangles happen to have the same interior angles. How do we know that? Because these ladders are parallel. Since they're parallel, and technically these 2 sides are parallel, and you use 3 here, these are all parallel. Because all the sides are parallel here, or they're all in the same spot here, the interior angles are all the same. So, because they're all the same, we use a ratio, sometimes referred to as the k-value. To figure out our missing sides of a similar triangle. So I'm going to break this into 2 triangles now. Triangle 1, we're going to do here in black. It'll be the larger triangle. It was, try to do a little more to scale, because that was not a very to scale picture. This one will be a little more to scale. Not perfect still, but it was 10 units here, 4 units here, and 9.1 units here. Our second interior angle, not be perfect, but say it's something like this. This unit, the hypotenuse of this triangle is 6. So, like I said, we're going to use a ratio value. Because these two are the same side, the hypotenuse, so this is the hypotenuse of this triangle, and this is the hypotenuse of this triangle, we find the ratio between these two values. So, like I said, it's usually called the K value. So in this case, I need to know, how do I take 10 to 6? And we don't add or subtract. When we're doing ratios, it's either multiplication or division. So to go from a larger number to a smaller number, we're dividing by K. Or vice versa, you can figure out how to take 6 and change it to 10. Well, we're going from a smaller number to a bigger number, we're usually multiplying by a value, okay? So we multiply by K. The ratio works either way. So in order to figure this out, we got to figure out what this K value is. So we can say 10 divided by K equals 6. So we're going to set up that little formula here. So 10 divide K is equal to 6. Well, we got to isolate K, get it by itself. So it's a fraction here. So I'm going to bring it to this side, and when I do that, it's going to be multiplied by K. So we have 10 is equal to 6K. Still, we want to get K by itself, so we're going to divide both sides by 6. Okay. We're left with 10 divided by 6 is equal to that value K. And 10 divided by 6 is going to be 10. I think I used two different calculators here. Oh, sorry, I did 10 divided by 2. I'm like, well, that doesn't make sense. There you go. 1.67, you could say, but 6 repeated. So K is equal to 1.67, and I'm going to say approximately. Okay, so this K value, we're going to replace it. These two Ks. We're going to replace it with this value here, 1.67. 1.67. So we divide by 1.67, or we multiply up. Now, because we're going from we have more information. In fact, we have all the information about the bigger triangle. We're going to constantly be dividing. Think of it like we're shrinking. We're going down in size. So I'm going to take 9.1, and I'm going to divide it by the K value to find out that side. I'm going to take 4 and divide it by the K value to find out this side. So once you have the ratio, you just apply the ratio to the other two, and you'll have it. So 9, we're going to have a lot of funny arrows here, but 9 divided by 1.67, bring it up in our calculator. Let's go back to our other one. 9.1 divided by, that's not the right value. 9.1 divided by 1.67 equals 5.45, we'll say, 5.45. So this is 5. Say that right? 45, yeah. And then with the other one, same idea. Take 4, and we're going to divide by the K value. And it's going to become 4 divided by 1.67, 2.4, let's say. This becomes 2.4. I know it's a little jumbled in there, but the key here is once we find that ratio, you just multiply or divide the other sides by it, and you have all of that information.